Morning, everybody. This is BS Rajadi again with our subject energy engineering for final year engineering students. In some universities, as power plant engineering for third engineering students. So, before starting with lecture number 11 or this introduction and thermal power plant, some revision of the lecture number 10 that we have seen coal, that is polarized fuel and polarizers. In brief, we'll brief it and then proceed for the new topic, ash handling system. So we have seen, I'll show this with the slideshow, so it will be better. Okay, so coal classification we have seen. Sorry. Coal classification, there are four major types: anthracite, bituminous, subbituminous, lignite, bituminous, and subbituminous, mostly found in India. The highest coal generator is USA, China, and India, then India. So coal quality can be analyzed by ultimate analysis and proximate analysis. These analyses are being carried out at mines where or at if the transportation is by trains, rails. So the analysis have been carried out at that site and also in the power plant. So these analyses are useful, whether what is the quality of coal and how much kilocalories or HCV, calorific value of the coal. From that you can decide how the combustion is being taking place inside the furnace. Coal beneficiation or coal preparation, we have seen. So this raw coal coming from the coal mines is being distributed over the rotary breakers and number of you will see the crushers by means of grinding taking place. Yes, this is the crusher. This is the single deck screen. This is double deck screen. Screening takes place from these various 2 points, and then it is being again screened to 6 mm, and then goes to the bunker. Again, this vibratory feeders here also vibratory feeders are there. With the help of these barrel drums, they are being collected through the clean coal bunkers, collected to clean coal bunkers with the help of dewatering screens. This is in brief about coal beneficiation. Coal blending is mixing of the coal, high grade and low grade, in order to achieve the cost effect. Coal selection for thermal power plant, we have seen there are a number of steps while selecting the coal, isn't it? So we already know proximate analysis and ultimate analysis. Then one more, high grade grindability index, hard grindability index. Higher the this HGI, higher the softer the coal. Lower the grade, you will get harder the coal. Okay, so then this test that we carried out in the you can say at site or in the labs. Then actual tests are being carried out by drop to furnace or emission performance test with the help of coal mills and all this at site with few weeks or hours or few days, and then it is decided the type of coal which is required for the plant and whether it is capable to generate more steam, isn't it? Then we see the fuel slurries. The mixture of solids and liquids is called a slurry. So nowadays these slurries are being used in order to transport, in order of transportation. They are mixed with water. Okay, so can be used for boilers. Some impurities can be removed and also its transportation condition will be better, non-flammable, and eco-friendly. Okay. So polarized fuel system, there is a fine polarized means fine particles. Fine handling systems. There are two system: unit system and central bin system. In unit system, there are you are see separate polarizers are there and separate, and they go separately to the through the pipe. The polarized fuel flows through the pipeline to the burners. Whereas in case of there is a centralized polarizer itself, and then it is collected in the central bin, and as per need, it is sent through the feeder to the bunkers. That is the difference between unit system and centralized system. We have seen some advantages and disadvantages of this unit system and centralized systems. Then we saw the polarization. Polarization is actually in our plant 210 megawatt and also 250 megawatt. I have seen this polarize up to 200 mesh, that is 0.075 mm. So it will pass through then 50 mesh and goes to the furnace for burning. Types of polarizers we have seen: ball tube mills, then ball mills and roller mills and high impact mills. There are three types. Okay, the purpose of polarizer is to supply polarized coal to the boiler as per requirement. Transportation is easier, to remove the moisture and to remove high density in organics, and also it is beneficial that a maximum percentage of coal will come in contact with the air and then burn. So burning efficiency will be much more with the help of a pulverized coal. Percentage of unconburned particles will be reduced. Coal parameters after affecting pulverizer output, that we have seen HGI normally is taken, means you can say their datum is 50 HGI is taken for calculating the base capacity of the mill. When coal is with higher than 50 is fed to the pulverizer, the output will be higher than base capacity, and below 50 HGI the output will be lower because it is a grindability will be less. Okay. Ball mills we have seen, we have studied this line diagram. Then ball and race mills, the difference here you have seen here, upper race and lower race. Between upper and lower race, the ball is being placed, upper race is stationary, lower race is being rotated with the help of worm and worm wheel. And when the coal comes in contact with this race and ball, and by rotation the coal is crushed to fine particles and sent through the classifiers to the furnace. In ball mills, we saw there are steel balls in the drum. So whenever they are coming to the drum through the feeders, they are being crushed to a finer size, and fine particles then passing through the classifiers to the burner. Okay, the heavy particles again return back to the drum and get recrushed. Bowl mill. In bowl mill, we saw there are 3 rollers, and we have worked on this in 210 megawatt plant. So these rollers can be adjusted with the help of spring mechanism, so that you can see that coal is to be pulverized to 200 mesh, passes through the classifiers and then to the burner. Okay. Then we saw the advantages and disadvantages. Most of the advantages use this ball mill in the power plant than ball mill. Okay. So this was about pulverization system. Now let us start with the today's topic, that is ash handling system. So we'll go a little faster. So as seen in the first class, that ash handling system, just to want to show where it is. This is general layout of the power plant. Coal is coming from the coal handling plant. Then it is in the boiler, water is there in the tubes or in the shell. Then it is being heated to convert it into steam. Then this steam is taken to turbine for electricity generation. Whereas after burning of this coal, there are 2 types of, I have read to ash being generated. The ash is in the 2 forms we saw, that is bottom ash, the the ash which is falling down, and then the fly ash which is flowing along with the flue gases. This ash is being then collected with the help of ash handling plant, and then it is sent to the ash storage, and it is sent to the sump, or you can say outside. Okay, so this is in brief. So we have seen in the first class. Now, what is this ash handling system and ash handling plant? Let us today uh, elaborate it. Ash handling: a huge quantity of ash is produced in the central station, sometimes as much as 10 to 20% of the total quantity of the coal burnt in a day. So usually for 210 megawatt, where I worked for more than 29 years, there we saw that approximately 3,000 to 3,500 tons of coal for one unit. There were 3 units, so total around 10,000 tons required per day for generation purpose. Then 10,000, if you can say 30% approximately the ash content, then it will be 3,000 tons of the ash was generated, and it is a quite complicated one and quite even health hazardous one. But you have to remove this ash continuously in the thermal power plant. So here it is written, seen that 10 to 20% here told the quantity of coal is burnt in a day. So there are therefore hundreds of tons of ash may have to be handled every day in large power plants. Handling of ash includes its removal from the furnace, and then loading of the on the conveyors and delivery to fill or dump into the sump from where it can be disposed of. So we can see that ash handling system consists of, so you know that boiler furnace have bottom furnaces. The large ash particles are collected under the furnace in a water-filled ash hopper. So this system we had. So though after combustion, the heavier particles fall down in the bottom ash. We call it as bottom ash hopper, and then they are being, and the fly ash, which is, I just told, collected in dust collectors with the electrostatic precipitator or bag house. We were having this electrostatic precipitants where I worked also. PC means pulverized coal boiler generates approximately 80% of fly ash and 20% of bottom ash. Ash must be collected and transformed from various points of the plant's ash. The figure will be next. So which are rejects from the pulverizers are disposed of the bottom ash system. 3 major factors should be considered for ash disposal system: plant site, fuel source, and environmental regulations. Considering these 3 points, then only you have to go for disposal. Okay. Ash handling system. The modern ash handling system may be used. There are gravity system or hydraulic system, and pneumatic or vacuum system, electrostatic precipitation system, and mechanical dust collector. Let us see in brief one by one. So this, you have to know what is the ash handling and what are the systems, methods to remove, types of ash handling system. So in gravity system, there are 2 types again: low pressure system and high pressure system. In low pressure system, with the figure itself, I will explain. So you will be seeing this. These are the water troughs, dark lines. And then water is flowing through these troughs. First, you will see, concentrate on this. This is the boilers you are seeing. So from the boilers furnace, the ash is falling on these troughs, and with the help of water, high velocity water, you can say, high velocity water, it is being sent to the ash sump. Sumps are used alternatively for settling out. So in one shift, you can say this trough may be used for collection of sump. In the next second shift, you can use this another trough for collection of the ash into the ash sump. So that settling time will be there. Ash will be settled there, and the water which is flowing upwards can be reused for this collection of ash with the help of high water velocity. High water velocity can be obtained. Velocity can be obtained with the help of pump or hijectors. We were having hijectors. With the help of hijectors, this ash is being disposed to the ash sump through the troughs. So same thing is here. Low pressure system. There are four, you can say, troughs. So these troughs can be isolated for maintenance purpose, or can be used one by one, or can be used four at a time and to be collected into the sump. This is about low pressure system. What is about the high pressure system? In this high pressure system, again the figure itself clearly shows here. This is the furnace. The ash is collected at the grate, from the grate, or you can say bottom side is you can say stoker, and then stoker it is falling down. While falling down, one you can say high pressure water nozzle is placed here, so that flows it down. Then while flowing again, there are high pressure water you can say hijectors are being placed in the system at the bottom ash system, you can say. And then this ash, after with mixing with water, flows down to the trough carrying water and ash, and this trough is being uh, delivered to the main sump with the help of gravity or with the help of pump. This is about the high pressure system. So this function of this first nozzle or ejectors in the upper side is to extinguish, because it is very hot when falling down. So first it is extinguishing of the ash takes place in the first nozzle set, and then when the file falling down, then ash is mixes with the water, and then with the high velocity of water, it is being sent through the troughs to the main sump. Advantages of gravity system: the system is clean and healthy. It can also handle molten ash. The working parts are not exposed to ash. It is dustless and totally closed. That is most important, so that it is not hazardous for the people working around the ash or boiler. Okay, discharges the ash to a considerable distance. So this one is most important. You can send it to the longer distance than the power plant and dump into the lake, or you can say pond, which is away from the plant. High ash carrying capacity. Very good. So pneumatic system. So a line diagram again is shown in pneumatic system. This pneumatic system also I have seen. So this boiler is there shown. This ash is being collected through the crusher. We were calling it as a crusher as grinders. After grinding this ash to the finer particle, mix up with water with the help of hijectors, or here it is shown air or steam. With the air pressure, the ash in the particle form is being sent through the separators. Ash separators are seen here. Then they are, while falling down, air flows upward direction with ash is falling down in the collected in the hoppers, and with the help of this again water nozzles or water hijectors, this ash being disposed to the you can say ash sump, and then been taken to the through the troughs, and then been taken to the ponds. While flowing the ash air along with some fly ash flowing through the filters, these filters removes the ash contents, some of the ash contents here, and then it goes to the exhauster fans. It is also called as induced draft fans. Then it goes to the chimney. Okay, this is about pneumatic system. Then this is electrostatic precipitator system, which we used, and it is used in almost all the thermal power plants. So it is one of the best methods to remove 90%, 90 to 99% of the ash is being removed. Fly ash, that is, means the ash which is flowing along with the flue gases is being collected in the electrostatic pressure. The efficiency of this ESP is about, I told, just 90 to 99% of the ash is being removed from this electrostatic pressure. Let us see what is that electrostatic precipitator system. It consists of, first of all, you see this control cabinet, high voltage transformer, 440 volt, 50 hertz, three-phase supply, usually same for almost all power plant. There is a rectifier, then 40 to 80 kilowatt DC, converting this into DC, and that DC voltage is being then sent through this emitting and collecting electrodes, and electrostatic field is being produced inside the ESP, which makes the ash which is coming from the boiler, you can say, if suppose here coming from the ash boiler, so number of rows are there of these collectors and emitters. This ionization of the ash takes place due to the electrostatic field inside the electrostatic precipitator. Positive and negative ions are being formed. They are attracted towards this opposite charged collectors and emitters, and the clean gas or almost clean gas then flows. The ash particles attached here and the clean gas or flue gas, we say it as, then it is flown to through exhauster fan or ID fan to the chimney. Okay, so here is same thing. Sources of high voltage required, ionizing and collecting electrons, dust removal mechanism, shell to house elements. The precipitator has two specific electrodes insulated from each other, that is cathodes and anodes, or you can say collectors and emitters, that maintains electrostatic field between them at high voltage, about 40 to 80 kilovolt DC. The field ionizes the dust particles that pass through it and attracting them to the electrode of opposite charge. The high voltage system maintains a negative potential of 30,000 to 60,000 volts with the collecting electrodes grounded. The collected electrodes have large contact surface. Accumulated dust falls off the electrode when it is wrapped at a regular interval. Wrapped means there are wrappers, hammers. The hammers, they hammer this collecting electrodes plate and emitting electrode plates, so that whatever the ash collected on the plates is fall down in the hoppers, and with the help of high velocity water, with the help of hijectors, sent sent to the ash sum through the troughs and then to the lake or pond at longer distance. So if this, you can see this type of mechanism we have seen, and is most commonly used in almost all plant due to its higher efficiency. Then the whatever the electrostatic field, electric field is being generated inside the electrostatic field, which is there inside the electrostatic precipitator due to the high voltage DC current. This phenomena is called as corona effect. Due to this corona effect, the ash ionizes into positive and negative charge, and they are collected. They are attracted toward emitters and collectors accordingly with the charge. So this is the best way to remove the ash. We'll see the advantages of this: effective removal of small particles like smoke, mist, and fly ash, easy operation. The drought loss is quite less. The most effective for high dust loaded gases. Maintenance cost is minimum. So here you will see maintenance cost is less. Okay, no problem. And ash disposal is also very nice. Ash removal is very nice. Some of the disadvantages you will see: space requirement is more because there are number of rows, number of cathodes and rails. So it's the space required for this ESP is more necessary to protect the collector from sparking. So due to the electric current and all this, there's chances of accidents of sparking, etc. are there. High running cost, high capital cost. Initial cost is high, but overall, if we see the removal, if we consider the removal as the you can say point, then it is the best method. Mechanical system. This figure shows the mechanical system. There are the boiler furnace, ash being connected at the bottom in the form of grinders or and the crushed, or you can directly falls on the water trough, and this water trough, this ash cooled by water while falling down on the belt conveyor and is carried out. Means there is a water hopper, and through then the water hopper is cooled down, and then it is it is taken on the belt conveyor, where it is sent to the bunker. This Along with water, this ash is being then collected. Water is being drained and ash is being collected directly to the transport or trucks to the, you can dispose it all. Okay, so this is about ash handling system. I hope you understood. I have tried my level best to explain it, each and every one method, this ash handling system. Okay, we'll stop for today. Thank you very much.